course, you also need to have Java and Eclipse installed properly. See the email I sent you earlier. Okay, and that email is also available on Piazza. It gives you all the details what you need to do. So by now, hopefully, most of you or all of you already have this environment, so you can practice as we go. One more thing I want to show you. So in the examples, the content I provide has two folders. One is the lectures. These are the PDF of the lectures. And the other one are examples. So the way you open these examples, one way, this simple way I usually do, I copy the location of these examples from the Windows Explorer. I go to my Eclipse. I go to Eclipse, I open Eclipse and go to File and then File Import. Can you see here? File Import. And then in File Import, I say, oh, please go ahead and import for me projects from the folder. So I choose this option here, go next, and then I can browse and get that folder, or I can just paste that location here. Then this will give me all the folders that are available, and this is the one I want to import to work with. And I can import examples 03 OOP basics, and then finish. This will open it here, and that's it. That's the idea. In here, for example, I have three examples. One is simple bank we did together, and one is a little bit more advanced. I will explain some aspects hopefully today. And there is another example which is QU Bookstore. So here I'm providing you three examples. Of course, we cannot go through all the examples in class. So I'm providing you for your own self-study, and you can go through them, try to replicate them, try to improve them. This is very critical. Okay, this is just to remind you of this. Now, moving back to the object-oriented programming in Java, those are the concepts that we have covered so far. So I want to go through them again, explain them in a little bit more details, and if needed, I can jump and show you some examples. So first, by now, hopefully you already know the difference between classes and objects. So let us quickly revise this. So what is a class? Blueprint that we create as many objects as we want from the. Very good. Yes. So basically, you can define it as the definition of the object. So class is a definition of the object. And also, when I create a class, what I'm creating? A data type. And so a class is the definition or the data type, and the objects are instances, examples of this class. So I can create as many objects from a class as I wish. Okay. Now, in a class, what do I find in class? When I define a class, what do I define inside the class? Two things: attributes and methods. Okay. What do we use attributes for? Properties of the object. Properties that some variables where I will put some data about the object. Okay. So for example, in the account example we saw last time, what were the attributes that I defined for the bank account class? The ID, the name, the type, the balance. You saw these are attributes. And then there is in regards to attribute, there is a very important object-oriented principle. We call it. Yes, there's a very important object-oriented principle called encapsulation. What this principle says? Yes, this encapsulation principle says attributes should be kept private, and then you provide get and set methods. We call them getters and setters to read and write to the attributes. Okay, so why do we keep the attributes private? So they don't just get changed. Sorry? So no one can. Yes, so no one can accidentally change them, or we control the way we change them. So let me show you an example here. So if I go here, in the example we saw last time, you see I marked all the attributes with this keyword private, which means these attributes are not visible outside the class. And now anyone who wants to read or write to this attribute, they need to go through the get and set methods. So for example, for the ID, I have a get method and a set method. You can see here the get. I use the verb get. This is a standard verb. I shouldn't use something like read or give me the ID or return me the ID. Instead, we use a simple verb, standard verb, get, followed by the name of the attribute, except that the first letter of the name of the attribute is capital. This is the standard way of writing a get method. And then the return type is the type of the attribute. What is the data type of ID? Is an int. So what is the return type of get? Is the same type as the attribute. And typically the attribute only returning basically that particular attribute, returning it to whoever wants it. Now you can see here, have a look at the set method. Can you see here the set? So here I'm saying set ID, and I'm taking a variable called account ID. And before I write this to my ID, what I'm doing here? Validation. Data validation. So what I'm doing here, data validation, which means if the account ID is negative, I will reject it. I will not allow it. If the account ID is positive, then no problem. I'll take that account ID you give me and store it in the attribute. So the reason why we use encapsulation is to protect our attributes, and we can do some validation if we wish. Now for the parameter, it could be different name as the attribute. Can you see here the name is ID? I can have different name, but it's very common to have the parameter the same name as the attribute. But if we do this, the compiler will be a little bit confused here, because we have an ID which is a parameter, and we have an ID which is the attribute. Can you see it? We have two. So the compiler, the poor compiler, is now scratching its head and say, which one is which? Okay. Yeah, we have to help this compiler by telling them, oh, by the way, this one, I mean the attribute that I define up there. And by default, of course, the priority is always given to the local variable, which is the ID. So there's no confusion. This ID is referring to which variable? The parameter. Okay. This one is referring to which variable? The parameter. All of them referring to the parameter, except if we want to refer to the attribute with the same name as the parameter, we use the keyword this, which means take a look at the attribute defined in this class. Okay. Now another reason why we should use encapsulation, which means making the attribute private and providing get and set, is sometimes we don't want the outside world, or we don't want others to come and change our attribute. For example, the balance. Can you see here the balance? I only provide a get method. Did I provide a set? No, because I don't want the outside world to come and change the balance the way they wish. If they really want to change the balance, what are the ways for them to change the balance?
Deposit and withdraw.
Yes, deposit or withdraw. Is clear? The idea is clear? Okay. Now, these attributes are private. We provide getters and setters to read and write to them. By the way, for getters and setters, you can leave them like this, or you can also put the keyword public. This keyword public is optional. If you don't put it, by default, everything is public, by default. If you don't put it, by default, it's public. If you want to be more explicit, you can put the keyword public. It's up to you. Okay. Now, what about method? What are methods? What are functions? Methods are basically functions, and a function is some unit that has a name. It takes some input. It does some work, and optionally some kind of computation, and optionally it might return some value to the caller. That's what a method is. A method is nothing but a function. It's basically a function. Okay. Now, another concept that we saw is constructor. What is a constructor? And what do we use it for? What it is and what we use it for? What do we use it for? No, we did. Okay, no problem. Let me explain it again, and I will go through the example. But we did cover it last time. Okay, here it is. So can you see, if I want to declare a variable x, how do I do so? Variable x of type int. Yes, so I put the data type and I put the variable name. This is one way of doing it. If I have some value in mind and I want to put it immediately inside and assign it to this variable, I can do so in the declaration. I can say something like this. So what this line is doing two things. Now, first is declaring a variable x of type int and initializing it with value 10. Yes? Now, suppose we have a class called account, and we want to create an instance of the class, or we want to create an object. How do we do this? How do we create an object from a class?
We use the class name.
We use the class name as the data type. Remember, when I create a new class, what I'm creating? A new data type. So I use it as a data type, followed by the name of the object. So it could be, let's say, Fatima account. Okay, I can stop here. In here, what I did, I only declared the variable, declared an object named Fatima's account. Yeah. Now this object has nothing. Yeah. Still has, in fact, it has a special value called null. There's nothing in there. Now, if I want to go ahead and create the object, actually initialize and create the object, what I will do, what's the way to do it? So I will say here equals, assign it, and do this new keyword here, account. This is how I create an object. In here, I didn't need to do new because this one is a simple data type. It's not a class. I immediately created the object equal the value immediately. But if the data type is a class, how do I create an object? One way. There is only one way. I have to do equal, a new, and the class name. Is clear so far? Okay. Now let me show you this. In here, of course, I can come here. I can come here and create the account, and then I start initializing the attributes. That's one way of doing it. Let me just remove this. Okay, so here, sorry, this is account. Okay, so one way to do it, I create the account and then start putting some values in the account. That's one way of doing it, which is similar to this. One way of doing this as well is x equal 10. I do it in two steps. First, I declare the variable, then I initialize it. Yeah. I can here also, if I wish, I can do it here also in three steps. So in here, I'm declaring the object. In here, I'm creating the object using the new keyword. And in here, what I'm doing? Initializing the attributes of the object. You see here, if I have 10 attributes, I will have 10 lines to do set. So what constructors allows me to do, it allows me to collapse all of this in one line. Declare the object, create it, and initialize it in one line, all in one line. Similar to this, you see here I can, instead of doing it in multi-lines, I'm going ahead and creating and initializing at the same time. Yes? So instead of doing this, let me just comment all of this. This is how I do multi-line comments. I'm commenting all of this. And then in the same line of the object declaration, I'll go ahead and say new account. And here I have the constructor. So I provide the ID, which is 123, the name, which is Sarah, and the type is saving. Yes? So what this line is doing, this line we're seeing here, what is it doing? Declaring the object, creating the object, and initializing the attributes, all in one line. You see these 4 lines here, in fact there were 5 lines, are equivalent to this one line. Yes? So to be able to do this, I need to create what is known as a constructor. Here is how the constructor looks like. So what is a constructor? Somebody tell me what's a constructor?
Function.
It is a function. Thank you very much. But it's a special function. What is special about it? Take a close look and tell me what is special about this function. Notice this and this. No. Can you see here? Thank you very much. Same name as the class. So constructor is a method that has exactly the same name as the class. What else did you notice? Can you see all the methods? What do we have in front of all the methods? Return type. Do we have any return type for constructor? No return type. So what is a constructor? No, there is not even a void. Is there a void? If there is a void, we put a void explicitly. Can you see here? Set, does it return anything? It returns nothing. That returns nothing, we have to explicitly say it by putting the void. Did we put a void for the constructor? No. So what is a constructor? It's a special method. What is so special about it? 2 things. Same name as the class. There is no return type. That's what a constructor is. And now, is it clear what a constructor is? What is it used for? What do we use the constructor for? Sorry? That is basically usage of the constructor. But what's the role of it? What I am doing here? And I'm not declaring. They are already declared here. What is the role of the constructor? What I'm doing here? Initializing. Initializing. What I'm initializing? The attributes. That's it. So, to summarize, what is a constructor? Special method. Has the same name as the class. Has no return type. Used to initialize the attribute. Is clear? Yes? Okay. Now, what I have here, just to explain, sometimes those of you who had the experience of opening a bank account, so you can walk into the account, to the bank and say, with 0 money, you have no money in your pockets, you have no money with you, and you tell them, please open a bank account for me. No problem, they can go ahead and open their bank account. What will be your balance when you open the account? 0. This is scenario 1. This is the poor guy scenario. They still want to open an account, they walk in, and the account will be open for them with 0 balance. Now there is another scenario where rich guy scenario. They might have maybe 1,000 riyal with them, and what they do? They create the account with some balance initially, with some initial balance. Okay. So in here, this initialization, does it support creating a rich guy account? No, this is only for the poor guy account. Now what I can do, I can create another version for the rich person's account. And what the difference will be between this version and the poor guy account? The poor guy version, it has one extra parameter, which is, Okay. Now what do I do with this balance that I got from the outside of the class? What do I do with it? I write it to the balance. Now the compiler will be confused. Do we mean I'm writing this variable to the same to itself? No, no. My intention is to write this balance to this attribute. But the compiler now is confused. It's considering that this one is referring to this. So we come in front of the attribute and say, no, my intention is to take this parameter coming from the outside, and I want you to take it and write it to this attribute. So to distinguish between the parameter and the attribute, we use this keyword this dot the name of the attribute. Yes. Now, how many versions I have of the constructor? 2 versions. One accepts how many? 3 parameters: ID, name, and type. And another version accepts 4 parameters: the ID, the name, the type, and the balance. Now, me as a user of this class, when I want to create an account, I say, okay, do you have somebody with you to create the account for you? You say, yes, I have 1,000. Then I will not use this version, I will use the other version. Yes, what I mean by this, if I, let me cut this one. In fact, if I come here and put the parentheses and put control space, it tells me this is a feature of the IDE. It's a feature of Eclipse. What you see here, this is called IntelliSense. So the program Eclipse is trying to help you by showing you how many constructors we have and what they expect. Can you see it? What this tells us, we have 3 constructors. One, it takes nothing, which means you do it this way. One, it takes nothing, you do it this way. Yeah. Another constructor, it takes 3 parameters. This one is for the poor man's account. And another one takes 4 parameters. Yes? So which one we use this time, because the person has 1,000 to deposit? We will use the second one. So we choose this. And now, even the Eclipse is still helping us, giving us some tips. Saying, okay, what's the first parameter? The ID, 1, 2, 3. Then it moves. It tells you what is the name. Then it says what is the type. And then finally, what is the balance? 1,000. Yeah? That's it. I created the account. Yes? I created the account. Now, if I go ahead and run it, the balance is now 1,500. Why is it 1,500? So we created the account, and then the person was walking out and saying, oh, I have another 500 in my pocket. Let me see, so I don't lose it. Let me go back and deposit. So I go back and say, okay, go ahead and deposit this 500. So the balance will be the initial balance used when you create the account plus the extra deposit. Is clear? The concept of a constructor is clear? Okay. How many constructors you can have in a class? As many as you wish, depend on the scenario. Yeah? So in this case, we have 2 scenarios, creating an account for a rich person and creating an account for a poor person. They have no money to put in their account initially. Yeah, that's basically the idea.
So it's based on the number of parameters, right?
Yes. And this feature you already saw in 151. Function with same name, different parameters. What do we call this feature? Function with the same name, different parameters. No. We call it function overloading. Function overloading. In this case, yes, thank you. So we don't call it function. Why we don't call it function? Because this function lives within a class. So it becomes a different name, method. Yes? So this feature, we call it method overloading, which is a feature that you already saw. What is method overloading?
Based on the input, the program will call the method.
Based on the input, the program will call the different version, the correct version, which basically, more precisely, method overloading is the ability to have multiple methods with the same name, but they must have different number and or different type of parameters. That's what what method overloading means. You can also do constructor overloading. What is a constructor overloading? You have multiple versions of the constructor. You see here in our case, um, we have three versions. One it does nothing. It doesn't have any. You don't initialize anything. You use it when you say, okay, I'm lazy now. Just go ahead and create the account for me, and later I will tell you the attributes one by one. That's scenario one. Scenario two, you want to create an account and you know the balance. You use another version of the constructor. Scenario three, you want to create an account, but you don't have a balance. You don't have any money to initialize the balance. No problem, you can use this constructor. So I have here three creation scenarios mapped to three constructors. Yes? Clear? So let's summarize quickly what is a constructor. Special method, same name as the class, no return type, used for initializing the attributes. And how many versions of such constructors I can have? As many as I wish, depending on the problem I'm trying to solve. Is clear what constructor is? Okay. Those are the basic build concepts of object-oriented programming. So let me go through a little bit more and just go through this very quickly if there is anything we didn't stop at. And I'm also repeating this again and again because I really want you to understand this, because this is the foundation. You will use it in this course, in other subsequent courses, and if you stay as a computer scientist or computer professional, you definitely will use these concepts. Okay, so moving on. So by now, this should be very clear to you. When I create a class, I am creating a programmer-defined data type. I'm creating a new data type that I define myself. And basically, objects are variables or instances of that type. So that's basically the difference between the two. A class is a type, and the object is a variable or an instance of that type. That's the difference between the two. So classes, the reason why we have classes in Java or in object-oriented programming languages is they allow us to create new types. That's the reason we have classes. That's basically, you really need to understand this by now. Because when you're creating a class, what are you really creating? A new data type. Now, when we define a class, what do we find inside the class? Attributes and methods. Typically, the attributes are private, and typically the methods are public, usually, but you can have private methods. I think better to remove this public, because methods could be public or private, but attributes should be private because of this principle of encapsulation. Yeah? Now, this is how I create an instance of a class. So I put the class name followed by the variable, the name of the object, equals a new, the class name between class name followed by parentheses. In here, what I'm really doing, I'm really calling a constructor. Yeah? In here, I'm calling a constructor that doesn't take any parameter. And I can have, as I explained, as many constructors as I wish. So just to keep in mind, when you create an instance of the object, you need to use the new keyword to really create the object. Now, The concept of a constructor, sorry, the concept of encapsulation, or this principle of encapsulation, is visually, you can visualize it like this. You see, the data about the object is private, is kind of protected. And around it, we have the methods. So the only way to get to the data of the stored by the object is through the methods, particularly the get and set methods. Okay. Now, the methods, these methods surrounding the object, the public ones, the method could be public or private, but the public ones, the public methods that the outside world can call, we also call them an interface. Just keep this in mind. Now, I will be repeating this and this again and again. You know, one of the distinctive capabilities or one of the strengths of humans is naming things. You will notice this not only in this course, in anything you do in your program. Okay, we are very good in naming things. Everything could give it a name. Class, object, even creating an object, we call it instantiation. And then initializing the object, the method to initialize the object, we call it constructor. Having constructors with different names, we call it method overloading or constructor overloading. You see here, every concept has a name. Okay, so this is not surprising. This is one of the things humans are very good at. Okay, and we know this very well. And even in the Quran, it says, وَعَلَّمَ آدَمَ الْأَسْمَاءَ كُلَّهَا. We are very, very good with names. So don't be confused. When you see some concept, it has a name, you have to know the name, because that's what humans are good at. They do this all the time. Yeah? It could be a simple concept, but they give it scary name, but you need to know those names. Otherwise, you cannot belong to a particular professional community or particular group of people, because they will start using those mustalahat and those terms and those terminology, and you will be scratching your head what they are talking about. That's why it is critical to really understand the concept and also know the name associated with the concept. Is this idea clear? Okay, now the public methods, the methods surrounding the private data that the outside world can call, what do we call the public methods? The interface. Yeah? Now the data is hidden. Why do we hide the data inside the object? We don't want accidental change. We don't want people to just come and put whatever they want in our attributes. We want them to go through a set method, and in the set method, we will have the opportunity to do what? Validation. We can validate what the input is before we write it to our attribute. Okay, we don't want any values. We can be more selective, and we can do some validation before we allow people to write to our data, to our attributes. That's basically the idea. And how we allow others from outside the class to read or write to the attributes, how do we allow them to do this? By providing them get and set methods. And this is not a must. It's up to us as developers. We might decide, for this particular attribute, I'm not going to provide set. And the example, you saw the example before for the balance. Did I provide set? No, because the business logic, the bankers, they told us this: please don't allow anyone to enter the balance directly. Except when they create the account first time, it's fine. But after that, that's it. You cannot set the balance directly. You have to go through the method, in this case, the deposit and the withdraw methods. That's the reason we have this very critical principle of encapsulation. So here is another example, just to visualize it. You see here, there is a black box here. Even this one, I think it shouldn't even touch the border. Anyway, I'll fix it a little bit. This one, it shouldn't even touch the border. I don't want it to be visible. This is a black box. The object is a really black box. You have everything Nobody can see what's inside. What's the only way to interact with your internal data that is managed by the object is through these methods. And these methods, what do we call them? The interface. Yes? It's exactly like us. We have lots of things in our mind. There is no way people know what is going on in our mind, what we think, what is our true perception of something, except if we explicitly tell them. We might tell them by talking to them, or we might tell them by facial expression, or hands expression, or body language can also reveal what's inside. But nobody can really tell what you're really thinking of, what you're really processing in your mind. Similar thing here going on. Yes? The only way is through the interface. Okay. In fact, we're not even supposed to make assumptions about what's inside the person's minds or thinking. We can only judge based on, we are only supposed to judge or to make decisions based on the interface. Either what you say or what your body language is saying. Exactly the same here. All the internal data is hidden. So I hope this is clear. Let's move on. This is just another visualization. I'm just giving you multiple visualization for the idea to really, really be clear in your mind. So this is what we did together. Remember the accounts we did together? So you see the attributes here are nicely protected inside the object. And then how we can access them? Through the methods, through the interface. That's the idea of encapsulation. I already explained this concept of a class diagram, UML class diagram. This is Unified Modeling Language. You will see this in software engineering, inshallah, as you move forward. But for now, just keep it in mind. There is a standard language to visualize the design of your class, how your class is designed. Not through the code. If you want to tell somebody, here is my class, here is the description of my class, please don't give them the code. It might be too scary, a lot of stuff. You just want to summarize the whole class in one picture. You know, picture worth more than 1,000 words. Yes, exactly the same. So in here, to visualize the class in a diagram, there is a standard way of doing this. This standard way of doing this, what we call it? Again, another term. We call it the class diagram. And what we find in this class diagram, it's basically a rectangle that has 3 parts. In the first part, class name. Second part, the attributes. Can you see here the attributes, what we have in front of them? Minus. What does minus mean in this context? It's a private. Okay, and the way we do it, we put the attribute name, colon, the value, the data type. Okay, this is how we express this in UML. And here I have a constructor. Can you see the constructor? It's called the GradeBook. You see here the constructor, the method name is exactly the same as the name of the class. And it has parameter name, which is type string. Then what I have here, I have a set course name. And it takes a string as a parameter. I have get course name and I have display message. And this plus in front of the method, what does it indicate? That these are public. Okay. Now, once I create a class, what I can do with the class? Create as many objects as I wish. Once I create an object, which is called, what is the process of, this process of creating an object, what is the term? Instantiation. Because an object is an instance of a class. You know the word instance? Plain English. Instance means another synonym for example. Okay? So when I say instantiation, what does instantiation mean? Sorry, can you please focus with me? Instantiation means creating an instance of the object. Creating an object from class is called instantiation. Once I create the object, then I can access the methods using the dot notation, the dot operator. You saw here, in the examples we had. Once I have the object created, then I can access the methods using the object name dot the name of the method. Yeah. So in here, for example, I am depositing. When I say dot deposit, what I'm really doing here, I am calling the method deposit. I am calling the method deposit. Now, when I say this get name, what this means, I am calling the method get name. And this one here, I am calling the method get balance. So I'm using the name of the object, then the dot operator, then the method I want to call. And this, of course, followed by parentheses. This is exactly the same as calling a function. But in here, we don't call it function, we call it a method because it lives within a class. So this is how I use the object. Now, instantiation is creating an instance of the object using the new keyword. So the consequence of doing this is exactly the consequence of declaring a variable. So if I declare a variable x, what happens inside our computer when a variable is declared? Yeah, so memory space is allocated, and it has this name, the name of the variable. And when I put some value here, this value will be assigned to this location. Exactly the same happens when you create an object. So some memory space will be created for each of the attributes. For each of the attributes, you have memory space. For example, when I create a new account, so I have memory space for ID, memory space for name, type, and balance. And what is the size of this memory space? Depends on the data type. Thank you very much. You can see here the role of data type. The role of data type is to help the computer decide what size it will be given to the memory location. Yeah? And basically the object is nothing but a pointer to that memory location. So the object allows you to access that memory location. And you can start reading and writing to those memory locations and changing them through the methods. That's what happens when you instantiate an object. Okay, and this is basically kind of trying to visualize it. So when I create an object, let's say an object pet, and the name, this is the name of the class is pet, and the name of the object is fish. So when this happens, a location will be created. This is for the name of the fish. This is the age, and this is the weight. Okay, and this memory location will be assigned to my object. So my object will be pointing to the memory location where all the attributes has been. Sorry, you really need to be quiet, or you don't need to come. Really need to focus. Okay, is clear? Clear so far? So when I create an object, sorry.
The object acts as a pointer.
Act as a pointer to the memory location that was created to hold the attribute of the object. Is clear? Yes? This is what happens when an object is instantiated. So before instantiating the object, as I explained before, in here I declared the object, but I have not created the object yet. So what will be the value of my, let's say, ship?
No?
It should be null, because it's not instantiated yet. Okay? That's basically the idea here. Now, once I instantiate it, then the null will be replaced by the pointer to the object that is created in memory. Okay, naming convention, I already explained these naming conventions. The class name, first letter is capital. Attributes, all attributes, the class name is a noun. Attributes are also nouns, and they should start with lowercase. And the attribute should be made private. Now the methods, verbs. And when you write them, the first letter is lowercase. Now if you want to create a methods to read and write to attributes, for reading you use the verb get for reading. And for writing to an attribute, you use the keyword, or not the keyword, the verb set. Those are the naming convention you need to keep in mind. Now for attributes, we use attribute to declare some variable to store data about the object, okay? And then each object will have its own attributes, of course. So you might have different accounts, for example. Each account will have different values for the attributes. So when you create an object, these objects are independent. They can have, of course, different values for the attributes. So in high level, in object-oriented programming, objects have two characteristics. They have what is known as a state and behave. State and behave. Okay. Now the attributes is what? The attributes are basically represent the state. Yeah, represent the state. So what I mean here, if I go back to this example, those attributes represent the state. Like state means like the current values of the account will be stored in the attributes. Now the methods represent the behave, which are basically actions that you can do on the account. So you can think of it, the attributes are data that you store inside the object, and the methods are actions that you can do. So you can call this, the first part you can call it state, and the second part you can call it behave. Yep. Okay. I already explained this. Attributes are nothing but local variables that you declare, and you mark them as private because of the encapsulation principle. Then you provide accessor methods, which are nothing but getters and setters. I already explained them. Yes, it's an interface to allow reading and writing. Those getter and setter methods, another name for them, if you hear this keyword accessor methods, they are nothing but the get to read and the set to write. Yeah. Okay. These are examples of this. And as I explained, why do we have this get and set? Is to prevent accidental change. And for set, before you set, you can do validation. And also you are not forced to provide set if you want to keep that attribute read-only. Then you don't need to provide the set when that attribute cannot be changed from outside. I think I stop here and I gave you the example of what set looks like. So in here, for example, the day and the month. The day must be something between 1 and 31. You cannot give me a date 50 or 500. It must be between this. Otherwise, I throw an exception. The exceptions, we will learn them later. For the month, can you see the month here? Yeah. Must be between 1 and 12. Cannot be something other than this.